Welcome pre-cal students to the homework help video, page 644, numbers 1 through 37, every other odd. Please have out your homework, your books, your notebooks, calculators, pens, pencils, everything you need. Let's go ahead and get started. Let's take a look here. Number 1, you are asked to plot this point right here, 2, 45 degrees. All right, so first of all we rotate 45 degrees, and when we do that we see we're on this axis right here. Now that's the positive part, down here is the negative part, and notice we want a positive 2. So on this 45 degree axis we're going to go up 1, 2. So there we go. Let's take a look at number 5. We're doing every other odd. Number 5, they want you to graph 1, 30 degrees. Now I know it says pi over 6, but that's the same thing as 30 degrees. So I'm going to rotate to my 30 degrees. Once I hit that line right here, that's going to be the positive part of the ray, and this down here will be my negative part. Okay? Right here. So we want a positive 1, so we're going to stay on the positive part of the axis. So 30 degrees, positive 1 would be right there. 30 degrees, positive 1. And then lastly, number 9, negative 315 degrees. So negative 315 degrees. And then we're looking at a positive 3. A positive 3. So I'm going to rotate negative 315. So in reality, that means I'm stopping 45 degrees short. If I start here and rotate 315 degrees, I would hit this line right here. Okay, trust me, that's right. 315 is here. Then this last 45 degrees here would put me to 360. Okay, so if I rotate negative 315, I hit this axis right here. So once I hit this line, that's the positive part of my ray, and then down here would be the negative part of my ray down here. Okay, but we are dealing with the positive part of the axis. How do you know that, Mr. Earhart? Because my number right here is a positive 3, so I know I'm going to be out 1, 2, 3. There we go, positive 3. 1, 2, 3. All right, so there we go. It's just that simple. Rotate 315, and then I use the positive part of my axis. Now if this had been a negative 3, then I would come down here and use the negative part of my ray. Okay? All right, moving on to number 13. Now they want us to give names to these ordered pairs. So let's start off with letter A. Letter A. Okay? Letter A, let's see here, students. Letter A is at 30 degrees. I can see that, so I'm going to go ahead and put 30. So when I rotate up 30, this is the positive part of my axis, so I know I'm dealing with the positive side. And it looks like I went up 1, 2, 3. So 3, 30 degrees. Pretty simple. Okay, letter B. Well, letter B is down here, so I'm going to start here and rotate all the way to 300 degrees. So I know I'm at 300 degrees. And when I do that, this is the positive part of my axis. So I know this number here is going to be positive. Now, a lot of you think it's going to be negative because you're going down, and that is incorrect. It's going to be positive because when you rotate to 300 degrees, this is the positive part of your ray. This is the negative part of your ray over here. So I've rotated 300 degrees, and I'm out 1, 2, 3, 4. So this would be a positive 4. Okay, letter C. Let's see. For letter C, I would rotate right here, which is 150 degrees, so I know I'm going to be at 150 degrees, and then this would be the positive part of my ray, and this would be the negative part down here. Okay, so I'm at 1, so positive 1, so 1, 150. And then letter D, looks like for D I would rotate in between 210 and 240, that would be 225 degrees. So if I stop right here, pretend there's, let me get rid of this confusion here. With this point D, I'm going to go ahead and draw an imaginary ray coming out, and that would be at 225 degrees, right in the middle of 210 and 240. So I would rotate to 225 degrees. And then once I do that, once I rotate 225 degrees, this is the positive part of my ray, I'm out 1, 2, a positive 2. So 2, 225. Okay, hope that helps. Let's go ahead and move on now to number 17. Number 17, they want us to write this ordered pair in polar coordinates. And they want us to use the smallest possible positive angle. The smallest possible positive angle. And that shouldn't be too bad. Okay, so here we go. Let's go ahead and write this in polar form. First of all, I know I'm going to be at positive 3 and then down negative 3 square root. So I'll be over here somewhere. I'm just kind of making that point up. Go ahead and draw your triangle. So I'm at positive 3 and down 3 square root of 3. So in order for us to write this in polar form, I've got to find this angle and I've got to find my hypotenuse. Now in order to find my hypotenuse, I would square a 3, that would be a 9, and then I would square 3 square root of 3, which would give me 27. Use your calculator if you need to. 3 square root of 3 squared gives you 27. Add those together, you get 36, and the square root of 36 is 6. So I found my hypotenuse. That's pretty simple to do. Now I've got to find this angle on the inside, okay? So the tangent of that angle would be opposite over adjacent, and these would cancel. So I'm looking for an angle that would give me square root of 3. Well, let's see. Tangent, here it is. Tangent of 60 is square root of 3. So I know this angle right here is going to be 60 degrees. And now they want the largest possible, the smallest positive angle. Smallest positive angle. Well, I can't go this way. That's negative 60. So I'm going to go this way. That's 300 degrees. So I know I've got 300 degrees. Okay? And then I know my length out here is 6. That's going to be a positive 6 because if I rotate 300 degrees, this is the positive part of my ray. This is the negative part of my ray. So it's a positive 6. So there we go. 6 comma 300. Okay, let's go ahead and take a look at number 21. Number 21. Negative square root of 2 comma negative square root of 2. Now first of all, I know I'm going to be negative negative, so I go negative negative, so I'm somewhere over here, and I'm not really worried if my triangle is drawn to scale. Negative square root of 2, negative square root of 2, so I have to find the hypotenuse and my angle. Now in order to find the hypotenuse, if I square the square root of 2, I get 2. If I square the square root of 2, I get 2. Add them together, I get 4, and the square root of 4 is 2. So there's my hypotenuse. I just used Pythagorean's theorem, so pretty simple. Now let's find this missing angle. So tangent of my angle is opposite square root of 2 over adjacent square root of 2. Well, square root of 2 over square root of 2 is 1. So I'm saying to myself, when do I take the tangent of a certain angle that gives me 1? Well, the tangent of 45 is 1. The tangent of 45 is 1. So I know in here I have 45 degrees. Now the direction said to use the smallest positive angle, so I know I'm not going to go this way. That's negative. I know I'm going to go this way. And so it's 180 plus 45. So I know I'm at 225 degrees, 180 plus 45. And then my hypotenuse would be a positive 2, because once I hit this ray, this is the positive part of the ray. This would be the negative part of the ray over here. And so I know I'm going to use a positive 2. So 2 comma 225. All right. And that was number, let's see, 13, 17, 21. Let's take a look now at 25 real quick. 25. All right. Number 25 is 5 square root of 2 over 2 comma negative 5 square root of 2 over 2. All right. Now, very quickly, we know we're going to be positive and then negative, so we're going to be over here somewhere. And we know that our length going this way is 5 square root of 2 over 2, and our length going down is 5 square root of 2 over 2. Now we got to find the hypotenuse and then this angle. Now the hypotenuse could be a little tricky. Let's see, the square root of 5 square root of 2 over 2 squared plus 5 square root of 2 over 2 squared. Now first of all, remember something. Whenever you're squaring a fraction, you square the top and the bottoms. Let's kind of work on that over here. If I have 5 square root of 2 over 2 and I'm squaring it, that means I square the 5, that gives me 25. I square the square root of 2, that's 2. and then I square the 2 down here, that's 4, and so 50 over 4. So what I end up with is 50 over 4 plus 50 over 4. And then if you add those two fractions together, you get 100 over 4. Notice they already have a common denominator, so 50 plus 50 is 100, and you leave your 4s alone. And then 100 over 4 is 25. 100 divided by 4 is 25, and the square root of 25 is 5. So that's a lot of work to get a hypotenuse, but the hypotenuse would be 5. Now to find this angle here, remember it's tangent of angle x equals, now look guys, it's opposite over adjacent. They're the same thing. So anything over itself is just going to be 1. 5 square root of 2 over 2 over 5 square root of 2 over 2 is going to be 1. So when do I get 1 out for tangent? 45 degrees. Tangent of 45 is 1. So I know my angle here is 45 degrees. So I'm going to rotate around 315 degrees. And then my hypotenuse has a length of 5. So 5, 315 degrees. Okay? Pretty simple. Not that bad, really. Okay, let's take a look now at number 29. Number 29, they want us to write this in rectangular form. So we have -3, 45 degrees. Now please be careful on this and watch what I do, please students, okay? Yes, I rotate 45 degrees. That's true. Yes, 45 degrees. But then it says -3, so I don't want to use the positive part of my ray. I want to use the negative part of my ray. Okay, so if this is 45 degrees here and I go backwards, this is 45 degrees here. And then my hypotenuse is 3. Let's go over that again. I rotated 45 degrees, which is what this said, but then it's not a +3, it's a -3, so I go in the other direction, okay? And the only thing I shouldn't have done is I probably should not have put an arrow on the end of this ray here because we stop right there. And so this is 45 degrees, and this has a length of 3. So if I want to find the rectangular coordinates, all that I have to do is find out how far over I am here, x, and how far down I am, y. And that's really easy to do. Remember, the sine of 45 degrees would be opposite over hypotenuse, so y over 3, and the cosine of 45 degrees would be adjacent, which is x, over hypotenuse 3. So multiply both sides by 3. 3 sine 45 equals y. Multiply both sides by 3. 3 cosine of 45 degrees equals x. And now students, we know what the sine of 45 degrees is. The sine of 45 degrees is square root of 2 over 2. And we know the cosine of 45 degrees is square root of 2 over 2. So I really have 3 times square root of 2 over 2 equals y. And over here I have 3 times square root of 2 over 2 equals x. And so what you end up with is 3 times square root of 2, put the 3 over 1, 3 square root of 2 over 2, and same thing here, put this over 1, you get 3 square root of 2 over 2. So the length of this line here is 3 square root of 2 all over 2. That's really sloppy, sorry about that. 3 square root of 2 over 2. And the length of this line going down here is 3 square root of 2 over 2. So notice I'm to the left of the origin, so my ordered pair would be -3 square root of 2 over 2. And then I went down, so -3 square root of 2 over 2. There we go. We converted it from rectangular form or from polar form to rectangular form. Let's try a couple more of these, okay? That was number, let me take a look here in my book. That was number 29. Let's take a look at number 33. Number 33. I'm going to go ahead and change this. I'm going to put -2, comma, negative 300 degrees. Okay, so -2, 300 degrees. 5 pi over 3 would be 300 degrees. So I'm going to rotate. Now watch carefully what I do. I'm going to rotate. Wow, that's really bad. I'm going to rotate. I think my mimeopad is turned sideways here. I'm going to rotate 300 degrees. Okay, so 300. There we go. And you draw your ray, but hold it. After, remember, that's your positive ray right there. It wants a -2, so you're going to have to go this direction like this, okay? This direction here. And that's the part you want over there, Okay, so I rotated 300, and then I noticed I wanted -2, so instead of going this direction, I go the opposite direction. And so what I would have had inside of my triangle here was 60 degrees if I rotated 300. So that's what I have inside this triangle over here would be 60 degrees. So I'm going to get rid of some lines here. So what I have is this ray stopping here with a length of 2, and my angle here would be 60 degrees. Now, in order to find the rectangular coordinate pair, all that I have to do is find my x value going this way and my y value going this way. So again, sine of 60 equals opposite over hypotenuse. Cosine of 60 equals adjacent over hypotenuse. Multiply both sides by 2. So 2 sine 60 equals y. And then what is the sine of 60? Well, the sine of 60 is square root of 3 over 2. So 2 square root of 3 over 2 equals y. You're going to multiply these together, put this over 1. Your 2's cancel, and so y is square root of 3. So your y is square root of 3. Now let's find your x. Multiply both sides by 2. 2 cosine of 60 equals x, and the cosine of 60 is 1/2. Cosine of 60 is 1/2, so I really have 2 times 1/2, and 2 times 1/2 is 1. So 1 equals x. Okay? So 1. Now if I asked you the name of this ordered pair, you would say -1 because you went to the left, so -1 and then positive square root of 3. So there we go. We took this ordered pair that was written in polar form, we wrote it in rectangular form. Not too bad. All right, let's take a look at one more and we're finally done with our homework here. Let's see what we got here. This should be number 37. Number 37. And what we have is -6, and I believe what we would have would be 150 degrees. So I went ahead and converted it to degrees, 150 degrees. Okay, so we're going to rotate 150 degrees like this, and when we do, we're left over with 30 degrees. But hold it, notice we have a -6, so we don't want this part of the ray. Instead, we're going to have to go the other direction, and we're going to have to go like this. If we rotate 150, instead of having the ray go like this, it's going to go like this. Okay, so now what we would have had is we would have had this with 30 degrees here, and now instead we go backwards. Now we're going to have 30 degrees over here, and my ray has a length of 6. And so we can find this pretty quickly. This would be my y, this would be my x, and so again I would have sine of 30 equals opposite over hypotenuse, and cosine of 30 equals adjacent over hypotenuse. Multiply both sides by 6. 6 sine 30 equals y. And then we're going to find the sine of 30. So the sine of 30 would be, sine of 30 is 1/2. And so 6 times 1/2 equals my y. So 3 equals my y. I'm going to cross this off and put a 3 here. And then cosine of 30. Cosine of 30 would be, cosine of 30 is square root of 3 over 2. Well, first of all, I got to multiply both sides by 6. That's my fault. So cosine of 6 cosine of 30 equals x. Multiply both sides by 6. And then the cosine of 30 is square root of 3 over 2. So I have 6 times square root of 3 over 2. Put your 6 over 1, and then you can see your 2 would cancel into your 6 3 times. So you end up with 3 square root of 3 equals x. So here's your x value. It's 3 square root of 3, and here's your y value, 3. So it looks like you went over 3 square root of 3 to the right, and then down 3. So this ordered pair right here would be 3 square root of 3 comma negative 3, because you have to go down 3. So there we go. So we took this polar coordinate and we rewrote it in rectangular form. Okay, rectangular coordinate form. So there we go. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.